XY axis to create 4 graphs. And for our friends playing from home, it is the 11th. Our homework's 831. This is what we did to start. But here's what we need. 4 graphs that meet this criteria. Not one line that meets all 4 things, but 4 different lines or graphs, quote unquote, that meet that criteria. So,
can we have more than one line per graph?
Can you have what?
More than one line per graph?
You are for sure going to have 4 different. So you should right now have an XY axis. Right? Y, X. You are going to make a line for A that neither increases or decreases. So up here, I'll probably draw that in red. Then a different line you will draw that decreases non-linearly. Then a different line that increases linearly and then decreases linearly. And then D, I bet you can guess, it's a different line, is consistently increasing.
I was asking, should we draw 4 lines all on the same graph?
Yes, that's why I said A, X, Y axes. So label your lines A, B, C, D. There.
What does it mean by neither increasing or decreasing?
Well, if you don't know, we'll talk about it together.
What's the starting point again? Does that mean by Y or X?
Just 831's your homework. Ruler, X, Y axes. You just need X, Y axes. No, you don't. We don't even need to care about the scale actually. Hazel?
What would the equation be for?
We do not care. We're not looking for equations. So like ignore, that's why I keep scrolling down, ignore all of this stuff. We're just diving right into 115. Henry?
Does it have to be an XY axis or just for a single quadrant?
I don't know that a single quadrant will give you enough space to do what it wants. It might. But I like working with all 4 quadrants. I mean, in general, we normally work with all 4. I don't know, think through. Excuse me. You might be able to make all those fit on the.
You have to write the rule for each graph.
No. Just draw a sketch. Yeah. It doesn't say make a rule. It doesn't say write equations. It just draw lines. We're drawing 4 different lines, graphs, whatever you want to call them. Some people take issue when you call something a line and it's not straight. So that's why I'm saying like lines or graphs or whatever. Yes. Well, TTFN.
Our old math teacher used to say, I don't know. Can you?
Mr. Hudson said that a couple
I do that
times.
sometimes. I also normally say gravity works, but I haven't said that as often this year. Hazel? Ta-ta for now. It's Tigger from Winnie the Pooh. TTFN. It's ta-ta for now. Ian's like, I'll see you later. TTFN means ta-ta for now. You know how awkward this is. You know that I'm going to ask you to move because this is exactly what I was thinking. So when I go to teach, when I go to sit down, I'll sit in the lap and that's a little weird. So Charlie, could you tell me how we could draw a graph that is neither increasing nor decreasing?
There would be a line that does not go up or down.
So what do we call that type of line?
X equals something. I forgot.
Back in elementary, we started to call like one way a certain thing and another way a certain thing. Hazel? A horizontal line. Now, some of you said the x-axis. Yeah, sure, your line could be the x-axis, but as long as this is neither increasing or decreasing, that is an example of my line A. It could be down in the lower part of the graph, could be right on the x-axis, could be way up the graph. Doesn't matter. It's not increasing or decreasing. There?
The only reason I had a question about that is because I wondered if it was either increasing or decreasing on the x-axis or y-axis.
Well,
If it's on the y-axis, then it's increasing.
Well, then it would just be
Next is no.
I love it when people don't even give the teacher time to answer the question.
I know, it's fun.
What axis depends on what axis? Y depends on X. So when we're talking about what is not changing, Y is not changing up or down as X does change. Because remember, maybe this is, okay, we'll say this is the height of the trees I planted in my backyard. And thanks to my dogs, they have not grown because they keep peeing on them. So while time keeps moving forward, my trees do not grow any higher. And I will probably have to replace them next year. And then get my dog to stop peeing on them.
Is this a real story?
True thing I'm frustrated about currently right now. Patrick, what about a graph that decreases non-linearly?
So it starts at a really steep downwards angle, and then it starts to get less and less steep.
Starts steep and then less and less steep, but still going down, right?
Yeah.
Like mildly still going down. Yeah, absolutely. And again, you could kind of have this anywhere on your graph. You could like literally grab it, move it, and it's still decreasing non-linearly because it's a curve. But to kind of support Henry's question of could we just use the first axis, I'm going to try to see, could we just use the first axis? Audrey, did you? Or first quadrant, sorry, I said that wrong. Audrey, what about a graph, sorry, Hudson, about increasing linearly than decreasing linearly?
So can't you just do a straight line and then another straight line?
Yeah, a straight line and then another straight line. So if we want to increase, we start by going up. Oh crap, sorry, I used the wrong color back there. This should be green.
That's not red.
I know, it bounces off the edge of the screen, that's the problem. Wait a minute, I think I maybe just figured something out. Oh my gosh, that never used to be possible. My mind has been blown. That's what happened. I actually changed the color of that. I didn't know you could do that.
Wow.
Mr. Hudson is the best when it comes to smart notebook.
I'm not the best. So, as Audrey said, a line going up and then a line going down as long as these are straight. Now again, I don't need that portion. So, we're still okay in just the first quadrant. And Alina, what about a graph that is consistently increasing? Yeah, positive association, linear. She's given all those nice vocab words. I'm going to do this in white. Sorry, just because orange doesn't really show up here. So starting from anywhere, because it doesn't tell me whether it's proportional or not, right there is our D.
Oh, I did
Time?
I did my D as a parabola.
Is that linear?
No.
So,
I thought it said constantly, not consistently.
so the problem is the consistently increasing means does the same thing each time.
I don't.
If you are consistent, you do the same thing each time.
I thought it said constant.
You're good. You're good. You're good. So if we kept increasing on the increase, like
Compound.
like compound interest rate, that would be more parabolic or like exponential. Henry?
Okay. Is it okay if you also made B a squiggly line going down because it's non-linear?
As long as it never increases.
Nope. Wait.
So that's going to be your issue. If your squiggly line actually takes the y value up at all,
Well, it could continue it. It could go up straight and then it could go down.
this says just decreasing non-linearly. It cannot increase at all.
I know. No, but I'm saying squiggly can also mean that it goes up and then it goes down, then it tilts to a slightly more down angle.
That's fine, but you keep saying goes up. We cannot go up if our graph is just decreasing. So, imagine, I forget what the story is, whatever like nursery rhyme, but there's a hole in the dam and the water's leaking out. You find said hole and you go stick your finger in. Now the water's your finger out and it keeps leaking faster, and then you like try to put some flex tape on it, and it kind of works, but it keeps leaking kind of. Like, so it keeps decreasing, but it might slow down its decrease at one point or speed up its decrease at one point. There, then gotta move on.
I came up with another line.
Copy this table onto your notes. You came up with what?
I came up with another line.
Sorry, we're moving on. We're sorry. We took way too long a couple days ago. We gotta stop with all the side, like, what you're saying is probably most likely right, but I'm asking everyone to copy this down, and if I don't have you do it, you'll be behind, and that'll become a thing. I'll take your question once you copy this down. So the top, our x's, are just consistent. -3, -2, -1, 0, 1, 2, 3.
Bottom is consistent too. Oh.
You better ship it to I think we've now done the
So, Simon, what did you notice?
They're all growing consistent. Like both of them.
Sorry, there are like 5 people talking that aren't Simon. What did you say?
They're all growing consistent.
How so?
For every, it's +4 for every x. It's 4x? Oh, 6x, sorry.
Ah, it's +6 on the y every time we +1 on the x. So this +6, +6, +6, +6, that's staying the same. That tells us this is linear. So please write down linear when you show that constant change that's happening. Hazel, do you have a question?
No, I just figured out the rule.
Ooh, so there's another part to the rule. Do you know the other part about where we start?
Y equals 6x plus 2.
How do you know the +2?
Because 0 is... When x is 0, y is 2.
Give me just a second. So some people are struggling to remember that this value is the when x is 0, because when x is 0, this is 0. So what we're trying to say is, what is y when x doesn't matter at all? 2. Because when x is 0, this doesn't matter. It's 0. So we gotta have 2. Question? Yes, we're taking this further now. So now, as we've all realized, yes, we already know this.
Would y... I feel like... I don't know. I guess would y minus 2 equals 6x be the same thing as the rule?
Yes. So if you modify this with algebra, right? Hazel's asking a really nice deep question. What if somebody told you that this relationship was 6x equals y minus 2? That's the same. That is still the rule. 6 times your input or independent value will equal the y value take away 2. This should always be true if this is our rule.
But it's not exactly in y equals.
It's not in the y equals form. You are right. So when we're used to writing rules, we're used to writing a y equals rule, but this is still accurate. I could still use this. It's just not the nice form of the rule.
You could graph that?
You wouldn't really want to. You would put it into this form before you graph it.
So it would be possible, right?
Yeah, because I mean, so where this gets tough is sure this is possible, because we could make like an XY table and plug in when x is 0 and do the math. When x is 1 and do the math. When x is 2. Like, so you can still do it, but it's easier to put it in this form first. Does that make sense? Like, they're both the same. Mathematically, they're the same. This is better. Simon?
Take the y, then subtract 2 and divide by 6.
Why would we divide by 6? Or are you trying to get x by itself?
Yeah, you're trying to get x. No, so then you can get x by yourself, so you can calculate what the x would be instead of what the y would be.
This gets kind of gross. So we already did the -2. If you want to know what x is y minus 2 divided by 6. So sure, that's also a rule that we could use.
But that's disgusting.
Now, I love like many questions you guys want to ask, but has anyone actually like figured out what our lesson's all about today? No, because we haven't gotten there.
The machines. The function machine input.
Everyone write this on your graph paper. Conjunction, junction. What's your function?
We don't.
A function is the defined relationship between an input and an output value that we talk about as independent and dependent value. So a function is when an output depends on an input, and this is defined by a rule. Now that rule we're used to seeing as our equation. Logan?
Okay, so here's a cool way if you ever forget like what depends on what. So you know how kids depend on their parents?
Mm-hmm.
And
Boy, howdy do
so
I.
basically younger people depend on older people. So basically Gen Yers depend on Gen Xers.
Oh,
So
yeah.
Y depends on X.
Actually, your parents don't depend on you yet, and some of your parents are probably not Gen Y, but I like the stretch attempt. But, of course there's a but. Not. Hey, you're gonna want to write this down.
Gen Y is millennial.
It's a U.
Oh, it is boomer. No, stop making it. I am deeply confused.
Gen Zers.
Gen Y is different from millennials or boomers. He's millennials, right?
Thank you. Crystal actually, instead of just doodling like she normally does while she's frustrated with you guys, she got frustrated enough she actually asked it. Why are you having this argument when you could just do the math and then like have time at the end of class to either do practice work or have that silly argument going? Please make sure this is written down. Not all rules are functions. And we're going to look at why. For example, one rule that isn't a function is like x equals 2. Or like x equals y squared. Or like we've got a few options and we'll talk about some of them. These rules are not functions.
I mean, you could turn them into them though.
No, you can't. Please stop. This is one of those times when I think I'm teaching above what you already know and I have something that I can like, I don't know, teach you. Logan?
X equals y squared can be turned into a function.
Logan! No, it can't.
Y equals the square root of x.
Do you need to leave?
No.
Because you're disagreeing with the expert in the room, which is silly. That'd be like when I go see my cardiologist, I'm like, actually, my heart's fine.
Or if anyone goes to any doctor and gives them a self-diagnosis, they go on Google.
So please stop, because you're not thinking about all sets of numbers that we talk about. You're limiting what you're thinking of, and you're wrong. I'm sorry to tell you that, but you are. And I feel like with you, I just have to definitively tell you, you are wrong. Y equals x squared is a function, but x equals y squared is not. And I will show you why. But you must wait and have patience. Logan, leave if you need to. I'm not dealing with this today. I just don't have the energy. I feel like crap. Leave if you need to. If you can't deal with me telling you that what you're saying is not right, seriously, there's the doorway. We're moving on. So all functions will have an input value and an output value. And actually, somebody might tell you something is a function, and then you start playing with things, and you realize, oh crap, no it isn't. And then you have to go back and tell that person, hey, this isn't actually a function because it breaks the one critical rule. And we're going to look at what that rule is. When you have a function, thank you, smartboard, such as 5x minus 7. So go ahead and write this down, y equals 5x minus 7. We could all probably look at that and from our study earlier in the year say, well, the slope is 5 or the growth factor is 5, whatever. And the starting point, quote unquote, is negative 7 or the y-intercept, whatever you want to call it. I bet you could figure all those things out. And I'm actually pretty darn confident that no matter what input I give you guys, what x value, you could, without drawing the silly little picture of a machine, put an input into the function and find out the output. But so that I've talked about what CPM is going to phrase things as, when they talk about functions, they call them a function machine, because in the very childish way of teaching, they want you to understand it is doing something, right? Machines do something. You put something in, something else comes out, right? So, like those machines at Cedar Point or whatever, when you crank the thing and you put a penny in and out comes your stamped whatever, it's no longer worth a penny because it is it's been defaced. And actually, that's illegal, by the way.
No, it's not. If it's not, well,
Simon,
I'm just trying to make a joke.
I think if it's not
Well, defacing currency is there's a law against defacing currency or destroying currency. So that's the gray area. But also because it's probably only worth a penny, they're whatever.
So it's pennies are worth 1.5.
I know, which is weird. Henry?
Then why are there factories making those penny stamper machines?
It's probably not actually illegal, but according to the law, you aren't supposed to destroy currency. If I light a dollar bill on fire, I'm ha ha ha, watch it burn, that's illegal.
But with lower currency,
But it's not right.
Depends.
Well, I don't know. I think
Well, it depends on how much the piece of currency was.
Exactly, because if I burn a bunch of currency and destroy it all, now the gold backing that sets the value of the currency gets all goofed up.
that was Joker's worst crime in a dark night.
So let's jump to it. Let's jump to what you need to know then. VLT. Write it down. You know what it means?
sounds like a sandwich.
I get to teach you something.
Comma or period?
Is it like
Period.
BLT, but
Sorry,
with
that just
BLT?
ended up long. That's a period, but
So it's an acronym.
Is it a vegan BLT?
Oh!
Oh,
it's not.
now I'm going to tell you the end. This is the end, and then we're gonna piece in the how we get there. The VLT, just making sure that we get there, because I only have 13 minutes left, is the vertical line test. This is how we determine if something is a function. What that means is if I look at something, a rule, and I draw a vertical line through it. What color haven't we used? Black. Green, red, purple, or white, regardless of which function I'm looking at, any of these vertical lines only hit that function once. So functions that, not functions, rules that somehow make our graph, I don't know, like a parabola turned sideways, that hits the vertical line twice, is not a function. And what this rule is actually getting at, here's what the vertical line test is actually coming from. And I need you to write this down too, please, because this is where we build the vertical line test from. But I just want you guys to go ahead and know it. Every input, like x equals 5, or x equals whatever. Write down an example. Every input, your x value, can only have one output.
What would be the equation for parabola here?
Now, x equals y squared. But
There's another but. Okay,
We all have to.
But
Miss Goldring claims that Mr. Hudson doesn't have one.
Wait, she claimed it?
Yeah.
Like a bunch of times.
I don't remember this happening.
I do.
I do. What did he say?
here's what we mean by that. If this is your xy coordinate, this is a function, actually. This is like a manipulation of sine wave or cosine wave, or depending on where this meets here. A vertical line will only touch it once at any one given point. But if I were to draw a horizontal line, I touch it a bunch of times. So like if I look at y equals 2, this function, because it is a function, equals 2 here and here and here and here and here and here and here. That's okay.
So where is it going to go?
But you're at the front of the room. That's what makes it awkward.
You want me to sit down?
Or like, stand not so close to me. That or maybe you should just take over. But
No.
You take
No,
over.
I know.
so, yeah, this is where we're getting deeper into the year that you guys don't know this stuff yet. This is a function. However, anything where, and this is what we were talking about with like the squiggly lines and stuff like that, if my function does this and then somehow does like that, this is not a function. It hits multiple times. Patrick? Now, there are really funky like situations that are not functions that have rules. You can use Desmos to play with those if you want. Hazel?
Are you done with the butts? Because I'm out of space.
Don't worry, my butt's small.
Wait, you both told the only thing right in there.
I said my butt small, like apostrophe, like butt is. So, here are two examples of rule. You good or no? Okay, I thought you were like mad that I moved on. So, as we talked about earlier in the year, a parabola is an example of like y equals x squared. And then any other modification to it. You could have a number in front of x. Excuse me, you could actually have a number in between here that would be your bx. B would be a number, but then there'd just be a single x. And then this is still your, I'm not even going to go deep into that because we're used to calling b other things. But that's a parabola, x squared minus 2. The reason it starts at minus 2 is when x is 0, 0 squared, 0, we start at negative 2, right down here. Anytime we have an input for x, say negative 3, what's negative 3 times negative 3?
9.
Positive 9, then minus 2, 7. So then we go to negative 3, we find 7, we put that point. But what's positive 3 squared? Also 9, minus 2, also 7. And that's where this is a function. This does work because here's what we're talking about with functions versus non-functions. A function that is a function. The horizontal line is okay. Remember, the horizontal line is fine.
So that's a function.
This is not a function. Here's why. Think about this as being, hey, you guys have stuff to learn. That's normally when you listen. Height and time, right? Time is independent. Height is dependent. Height and time. This would be saying that at the time of 5 seconds, my ball is at, well, they don't show it up here, but we could solve this. It would be an ugly number. Or use this. At 7 seconds, the ball is at a height of 3 feet. No, wait, it's not. It's at a height of negative 3 feet. No, wait, it's actually, it's not a function. It's not a function. A parabola, an actual parabola, flip it. Think about this. If something looks like that, guys, it's modeling the height of the ball as time moves on. So when the ball is going up versus when the ball is going down, it's hard to see if it's a straight line, right? But watch this. It's a parabola. Oh, sorry, guys.
Oh, wow, you hit my toe.
Now, there's no way for me to throw the ball and it come back like that doesn't happen. Like, okay, with a boomerang, sure, whatever. But like that whole thinking about it not being a function, you can't go back to that same point because think about this, and I know you guys always want to argue with me. You can't go back to that point in time. You can't be two places at once. Like, this breaks the laws of physics. This is time. So I'm not saying you can't do this. I'm saying it's not a function. Right? Functions represent like realistic possible situations.
And I'm reminding you that magic is real and friendship.
Magic is
Oh, goodness.
Friendship.
I forget even what I put on your lunch sheet stuff for today. So, I want you to take a moment before we run out of class time on your purple paper, on your orchid sheet where this gap is, draw a couple pictures, write a little thing about how you know something is or is not a function. You can steal my pictures from up here.
Wait, it's not a function or is a function?
Both. How do you know when something is or is not?
Well, if it's breaking the laws of physics, I would assume it's not a function.
Not a funky. Kind of funky.
Guys, if you don't write something on your paper when you later are working on the homework and you cannot remember, I will have zero sympathy. Because the textbook does not jump you to this quickly. I wanted us to jump to this so we can move quicker through our material. So, when we look at different situations on a graph, that's pretty easy to determine is it a function or not. The table work is harder. So as soon as you can, give me your attention back up here. We're going to look at these tables. Actually, I want you to take a moment before we all come back together. Determine, are A and B both functions? Are they both not functions? How do we know? So check through A and B. So remember, to be a function, an input can only have one output. But an output can have multiple inputs, right? So for an input, 7 maps to 6, -2 maps to 3, 0 maps to 4, 4 maps to 2, 9 maps to 10, -3 maps to that. Did we use any inputs twice? No. Did we use any outputs twice?
Yes, but that's fine.
Yes, but that's fine, right? Because this is the y value of -3, that's the y value of -3.
Are we learning trigonometry this year?
Oh, here's the reason this looks so weird too. Positive, negative, 0, positive, positive, negative, positive. There's no like order to our points here. But this is okay. I can do that. Different inputs can share the same output. When we go to B,
It's wrong.
why?
Because it's wrong. It's wrong. Because there are it's 2 and 2 on X, and then it's 9 and -8, which makes no sense whatsoever, so it's stupid.
This is not a function because two different two different outputs have come from the same input. Because I guarantee, that's tough when I say I guarantee. I guarantee not all of us are going to have this like down pat in our brain right now. if I was you, I would write notes to yourself, like even just to show x, y, in these two situations, and write this is not a function. Same x, different y's, not a function. That would be like saying when x is 2, we have a positive 9 way up here, positive 9, and then a negative 8 way down here. That vertical line is going to hit both of those because they're both the same x value. Henry?
Okay, I'm about to say a bunch of words that only about half of you are probably going to understand. But what about quantum entanglement? Or something can be both this and that at the same time because it has no perspective. Because if
So pause for a second. Well, yes, that question. But not everything that can happen or like that we talk about, that we theorize, can be represented by functions. Does that help? That like not everything, like we can talk about a lot of things. Not everything can be represented by functions.
yeah, I forgot that not everything.
Yeah. So that's the thing. Like functions have a very specific defined like how they work. And there's a ton of non-functions. Hey, guys, can we chill out? Because otherwise I feel like I need to make a scene each other.
So what?
So you're right. There are situations we'll talk about in physics and everything else that cannot be represented by a function.
So what category would that fall under?
Higher than 8th grade math. C. Is it a function?
No.
No. D. Ooh, be careful. This one doesn't seem to hit anything else. This one doesn't seem to hit anything else. I think we're safe. I think we're safe. D looks like we're safe. Right?
If you connect the lines in a
It doesn't matter.
Feels like cheating.
So Audrey's bringing up a really good point. This looks gross. Right? If I connect these lines,
It's an earthquake.
like, yeah, but that's not what we're asking. What we're asking is it a function? Yeah. Yes. It is. You actually can't connect any of them with a vertical line. There's no points that are stacked on top of each other. Horizontal lines are fine. And you can, so here's what Audrey's getting tangled up on. This is not a line. This situation is a scatter plot. It does not get connected. Like, it's not meant to be connected. It's meant to be a scatter plot. If we try to connect the scatter plot, that line is a function because we have to go from left to right. We don't like zigzag connect things. That's not how we do it. So I don't know what we could try to say this graph is showing us, but it's very different data. Like maybe this is like
Rolling a dice.
no, like sunlight a plant has in its height or something like that. Like there's some really discrepant data here. Like it's very, very different. Is f a function?
Yes.
Yes. Now you guys gotta get out of here. 'Cause I'm totally over time. Have a wonderful day. D. Yeah, these are the same. So it is a function. Yeah, it's trying to trick you. Same x's, but also the same y's.
I think I know what that really ugly graph was.
What? What would it be?
The popularity of organic
Yeah. Or it could be like, man, we have to have something that involves negatives. That's the problem. Like, time spent at the crap. Time can't be our x because negative.
Time travel.
No, I was gonna say like time spent at the casino and money made because like some people might be positive, some people might be negative.
I'm big
But-
negative.
Some people might be sideways.